Moving on to the next category of biological molecules, remembering that those categories were carbs, lipids, proteins, and nucleic acids. Lipids, unlike carbohydrates, lipids are hydrophobic. If you've taken a nutrition class, you know that lipids also have the most energy per gram or the most calories per weight. Carbs and proteins have 4 calories per weight, lipids have 9. If you're consuming a lot of lipids, that might not be good for you as a human, depending on the types of lipids you're consuming. But a fat little bird like this stores up on lipids before they fly south for the winter. Since lipids contain the most energy per weight, this fat little bird prefers to stock up on them for the intensely demanding migration south. So it's kind of like the birds trying to get a lunchbox that does not weigh too much. Lipids do some really important things for us, the most important being energy storage, but they also do things like insulation and cushioning. We all know about baby fat, especially on our posterior area. Uh, Simply put, this fat provides cushioning when we fall as we're learning to walk. In our diets, lipids are more like having a check from somebody rather than the cash of carbohydrates. You have to deposit the check in the bank of fat deposits, and then you have to withdraw the cash, the energy, at a later point to buy some ATP. Triglycerides are such named because they have 3 fatty acid tails and 1 glycerol head to them. These are the major dietary currency. Those 3 fatty acid tails there, they can be saturated with tons of hydrogens, or they can be unsaturated where some of those hydrogens have been removed. Whenever I talk about triglycerides, I just can't help but think of the movie Fight Club when there's I'm sorry, when they're stealing a bag of fat from the plastic surgery center because they want to make explosives with the fat, and the bag of fat goes I'm sorry, it goes over the barbed wire, and all of the fat starts spilling all over the place, and he's like trying to hold up the bag. I'm sorry, I know that movie is old at this point, but it's still a good one about the irony of humanism. All right, moving on from triglycerides, we have a second kind of lipid here, which is called a sterol. Sterols are huge molecules, and they're made from cholesterol. Cholesterol is necessary in your diet, right? And it's necessary because you have to make these steroid type hormones like testosterone and estrogen. Other steroid hormones of note are the glucocorticoids, like cortisol, which is released from your adrenal gland when you are stressed, and hormones called mineralocorticoids, like aldosterone, which monitors the sodium balance and the potassium balance in your body by influencing the kidney. Also, the bile that is made by your liver is made of cholesterol, right? Because as we've learned from a previous mini lecture, like dissolves like. So if you want to digest or break down any cholesterol based things that you're eating, you need bile, a cholesterol non-polar substance, to do that. Our third and final category of lipids is phospholipids. And these are very important for us here in this class because they form the basic structure of cell membranes. They look like a balloon with 2 strings on it, and the 2 strings are the fatty acids. They have this polar head. It's polar up here, so water loving. And then they have these 2 non-polar tails. So this is the first molecule we've seen that has both polar and nonpolar components to it. Cell membranes are composed of a phospholipid bilayer, or a double layer of phospholipids arranged very specifically. In fact, if you put phospholipids in water and shake them up, they'll form these little bubbles here. I mean, it might take a long time, like a millennia, but, you know, if you extend the timeline to infinity, anything is possible, which is also a quote from Fight Club. The polar heads of phospholipids are exposed to the water inside and outside of this little phospholipid. Right here's inside and here's outside, and that's water-based. And those polar heads are exposed to the water-based inside and outside. The nonpolar tails are like facing each other, and this forms a bilayer with a nonpolar region right in the center of it, sandwiched between those nonpolar heads. The polar heads are kind of like the bread, and I guess that nonpolar region is whatever you like to have inside your sandwich. Hummus, jelly, fluff, whatever it is that you prefer.